One of the most important pieces of information you can learn about your business operations is how long it takes to perform a specific task. For example, if you repair phone screens, you might find that the average time to repair is 5 minutes. You can use the exponential distribution using that average of 5 denoted here by lambda as part of the exponential distribution to determine the probability of a specific time. This is what the graph looks like, and it may seem odd that the average time of 5 only occurs about 7% of the time. And the reason that's the case is because there is the possibility of long times, for example, 20 or 25 minutes. However, those long duration repairs are offset by the much higher probability of having a repair taking 1, 2, 3, 4, or 5 minutes. To see how this works in Excel, I will switch over to our sample workbook. I have opened our Excel sample file, and that is 0403 Exponential. You can find that in the Chapter 4 folder of the exercise files collection. I have the average time, or lambda, in cell E1, and I also have a table on the left that will let me calculate the probability of a specific number of minutes for a repair. So I'll click in cell B2, type an equal sign, and I will use the exponential distribution function. That is expon.dist. First, I need to know my x, that is the value that I'm comparing. So that's in cell A2 for this particular calculation, then a comma. The lambda is in cell E1, but I need to use 1 divided by lambda, and that is a characteristic of the exponential distribution. If you don't divide 1 by lambda, you will get very strange results. So in cell B2, I'll type 1 divided by E1, and because I want this value to remain constant, the cell reference to remain constant, I'll press F4 on Windows. It's Command T on the Mac, then a comma, and I am looking for the probability density function, or point probability. So I will highlight false for this final argument, press tab, right parentheses, and enter, and I get a probability of about 0.1637. I can now copy this formula down to the remaining cells, so I will click cell B2 and then double-click the fill handle at the bottom right corner. I know that my mouse pointer is in the right place when it changes to a black cross. Double-click, and you can see that the formula has been copied down, and I see the individual probabilities. Now let's say that I want to calculate the probability of getting a value between 3 and 7. So I have already calculated my probabilities for 3 here, and then 7 here, but because they're point probabilities, I can't use them. I need to use the cumulative function. So I will go to cell E3 and then type an equal sign. And I'm going to subtract the probability of getting 3 or less from the probability of getting 7 or less. So I'll start by calculating the value for 7, that is the cumulative probability of getting 7 or less. So that's expon.dist. The value is 7, comma, lambda, and again, it needs to be 1 divided by lambda. That's in E1. I'm not going to copy the formula, so I won't worry about a cell reference. And it is cumulative. So I will highlight true, which it already is, and then press tab to get that. Then right parentheses, and I will subtract the same calculation for the number 3. I'll go through it a little bit more quickly. Exponential distribution, 3. 1 divided by E1, comma, cumulative true, right parentheses, and enter, and I get 30.22%. So the probability of getting a value between 3 and 7, inclusive, is 30.22%, or about a third of the time. And that makes sense with an average of 5.